This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at limits at infinity. And the first thing we'll do is refresh our memory on asymptotes from college algebra. Specifically, we're going to look at horizontal asymptotes. Now, horizontal asymptotes apply when you have a rational function. Rational means a single fraction. So you're going to have a top of your fraction and bottom of your fraction, numerator and denominator. I'm just going to refer to them as top and bottom. And then you're going to have the degree. Degree is your largest power of x. So you're going to have a degree of the top and degree of the bottom. So we're going to have three cases for the horizontal asymptote. Case 1. The degree of the top is larger. If your degree of the top is larger, then HA, horizontal asymptote, there is none. Case 2, the degree of the bottom is larger. For a horizontal asymptote, that'll be y is equal to 0. In case 3, degrees are the same. And I always show this with an example. It's easier in trying to write about them being in standard form and leading term and coefficient and degree and so forth. So let me show an example. If we have f of x is equal to 5x to the third minus 7x plus 2 over 3 plus 8x to the third. Very simple concept. Notice that degree of the top is 3, degree of the bottom is 3. So the degrees are the same. You take the number off the front of the x to the largest power, which in top here would be 5 and bottom would be 8, and you create a fraction of it. So a horizontal asymptote would be y is equal to 5/8. Now we're going to see why these are true using calculus in a little bit, but let's first look at some examples dealing with this. We've got f of x is equal to 3 plus x squared over x to the third plus 1. Now, in order to have a horizontal asymptote, be able to use these cases, you have to have a single fraction. That's what a rational function is. It's a single fraction. So we're going to create a single fraction out of this. Now this is a mixed number form, so I'm going to take the 3 times my denominator and add the numerator. So take 3 times the bottom, so 3 times x to the third plus 1, and then I'll add my top part, which is x squared. And your denominator stays the same. So again, I took this number, multiplied it by the bottom part, and then added top. Well, 3 times x to the third gives us 3x to the third. 3 times 1 is 3, plus x squared over x to the third plus 1. Now the degree of the top, degree is the largest power of x, degree of the top is 3, degree of the bottom is 3. So the degrees are the same. So a horizontal asymptote will create a fraction, taking the number off the front of the x to the largest power. So we have 3 over 1, or y is equal to 3. Let's look at this one. We got f of x is equal to 5x to the third minus 7x plus 2 over 4x to the third plus 1. Well, the degree of the top is 3, the degree of the bottom is 3. This is case 3 again. Degrees are the same. So for a horizontal asymptote, we're going to create a fraction, taking the number off to the x to the largest power. So this will be 5 over 4. So y is equal to 5/4 is our answer. I didn't really have examples of the other two, I guess. But let me put them on here just so you see them. Now degree is your largest power of x, so the degree of the top is 0, the degree of the bottom is 1. So the degree of the bottom is larger. And if I come up here, degree of the bottom is larger, a horizontal asymptote is y is equal to 0. And our last case, and say we have f of x is equal to x squared minus 1 over x minus 7. Degree, the top is 2, degree of the bottom is 1. So the degree of the top is larger, which means there is no horizontal asymptote in that example. Well, this one starts talking about what happens as we're studying a limit as x approaches infinity, as x gets larger and larger. Okay. So we've got f of x is equal to 3x squared over x plus 2. And we got our x value, and we got our f of x. First one is 10 to the 0. Well, 10 to the 0 is anything to the 0 power is 1. So if I were to plug 1 in for my x, I'd have 3 times 1 squared over 1 plus 2. 1 squared is 1 times 3 is 3. 1 plus 2 is 3. So 3 divided by 3 would give us 1. 10 to the first. If I plug 10 in for the x, I'll have 3 times 10 squared over 10 plus 2. 10 squared is 100 times 3 is 300 over 10 plus 2 is 12. Which, where's my calculator? There it is. Okay, so 300 divided by 12. You get 25. So then we got 10 squared, which is 100. So I got 3 times 100 squared over 100 plus 2. Now 100 squared times 3 gives us, what is that? 30,000 over 102. Which gives us 294.12, taken 2 decimal places. And 10 to the third, which is 1,000. So I'll put that in. So I got 3 times 1,000 squared over 1,000 plus 2. And so let me plug that in my calculator. 3 times 1,000 squared divided by 1,002. So that gives us 2,994.01. 10 to the 4th. So I got 3 times 10,000 squared over 10,000 plus 2. 10,000 squared divided by 10,000 2. 29,994.00. How many more of these do we got? 10 to the 5th and 10 to the 6th. Okay, we're just about there. So 10 to the 5th, I got 3 times 1 and 5 zeros. 3, 4, 5 squared over 1, 2, 3, 4, 5 plus 2. So we got 3, was that 100,000? So 3 times 100,000 squared divided by 100,002. And then that gives us 299,994.00. And one more. 10 to the 6th. So I got 3 times 1 and then 6 zeros. 3, 4, 5, 6 squared over 1 and then 6 zeros. 3, 4, 5, 6 plus 2. 1, 2, 3, 4, 5, 6 squared divided by 1, 1, 2, 3, 4, 5, 6. Okay, so that gives us 2,999,994. Okay, by building a table and having x go to infinity, and I know we just went to 10 to the 6th power, but you know I could continue it. What we're going to see, the limit as x goes to infinity of 3x squared over x plus 2. You can see as the x value goes to infinity, the y value, which is our f of x, which is the second row, keeps getting larger and larger. So this is going to infinity. So it's going out of sight. It's not converging upon anything. Let me save that. Limits at infinity. Page 01.pdf. There we go. Now let's take a look at some calculus to do this. We've got limit as x goes to negative infinity of 7 over x minus x over 4. Now the whole idea on this is, or the main idea I should say, let me put a note on it, is that if you have a number over infinity, well, let's just think about what this is saying. Now this is infinity, but let's put 1 there. 1 over 1, that's equal to 1. 1 over 2, that's equal to a half. 1 over 10 is equal to 1/10. 1 over 100 is 1/100th. And I know this is kind of redundant when I start putting that, but and then 1 over 1, a bunch of zeros. See how this is going from 1 to 1/2 to 1/10 to 1/100th? So this is going to be approaching, it's getting smaller and smaller. So limit-wise, it's approaching 0. So basically, when you got 1 over a real huge number, it goes to 0. Well, that's the idea of this. Now, if you have 1 over infinity, that's equal to 0. If you have 2 over infinity, 10 over infinity, doesn't matter what number you have over here, it's still the same idea. Now, before we can really work a problem, we have to have a single fraction. So on this one, I need to get a common denominator. Well, I got x and 4, so multiply these two together, and that'd be my least common denominator. So it'd be 4x. Now here I multiplied the bottom part by 4, so I have to multiply the top part by 4. So I got 7 times 4. And over here I multiplied the bottom part by x, so I have to multiply the top part by x. So we got limit as x goes to negative infinity of 7 times 4 is 28 over 4x minus x squared over 4x. Well, now I can merge these into a single fraction. So that's going to give me 28 minus x squared over 4x. Well, on these, you're going to divide everything in the fraction by the largest power of x in the denominator. Well, our largest power of x is x to the first, so we're going to divide everything by x to the first. So we have limit as x goes to negative infinity, and we've got 28 over x minus x squared over x all over 4x over x. So we've got limit as x goes to negative infinity, and I got 28 over x minus, and x squared over x, one of these x's can cancel, so that just gives us minus x over 1, or just x. And down here these x's cancel and gives us 4. Okay. Well, if I plug in the negative infinity for the x now. Now we're really studying the limit as it approaches that, but we can substitute it in so we can see if it's the case up above. So I'm going to have 28 over negative infinity minus negative infinity over 4. Well, it doesn't matter whether you have 28 over infinity or 28 over negative infinity, that goes to 0. So that's going to equal to 0. And here we have negative negative, which gives us positive. And we got infinity over 4, which gives us infinity. So this doesn't approach any value. It just keeps growing without bounds. Well, let's take a look at our original problem, see what it looks like. Press y equals, press clear. Got 7 over x, so 7 divided by x minus x divided by 4. And then graph. Now we're looking as x goes to negative infinity. So you can see as x is going to negative infinity, see how the y value keeps growing and growing? And it'll keep growing as I go to the left, keep going to the left. So it'll keep going up. And I know from a horizontal asymptote, I know it's not going to skim anything from college algebra, because once I have it as a single fraction down here, there it is, 28 minus x squared over 4x, the degree of the top is 2, degree of the bottom is 1, degree of the top is larger. It means there is no horizontal asymptote. So I know it's going to positive infinity or negative infinity, just from that. Let's look at our next one. We got limit as x goes to infinity of x squared plus 5 over 3x squared minus 7. Again, we want to divide everything by the largest power of x down below, and the largest power of x down below is an x squared, so we'll divide everything by x squared. So I'm going to have x squared divided by x squared plus 5 divided by x squared all over 3x squared divided by x squared minus 7 over x squared. So we got limit as x goes to infinity. X squared over x squared is 1 plus 5 over x squared all over. Those x squareds cancel, and we got 3 minus 7 over x squared. Well, now we're ready to plug in our infinity for our x. So let's go ahead and do that. So we've got 1 plus 5 over infinity squared over 3 minus 7 over infinity squared. Now, we said that just a number over infinity approaches 0, goes to 0. Well, if we have infinity squared, that just goes to 0 faster. So this is going to equal to 1 plus 0 over 3 minus 0, which gives us 1/3. Now think back to our horizontal asymptote. Degree of the top is 2, degree of the bottom is 2, degree is the largest power of x. You take the number off the front of the x to the largest power. So we'd have 1 over 3, which gives us 1/3. So we've already said our horizontal asymptote is 1/3, and you see that's what we get when we study the limit. So this is where that comes from in college algebra. Let's take a look at this one. Might not have room. Let me save this page. Okay, let's look at this one. Got limit as x goes to infinity of x over the square root of x squared minus 2. Well, our largest power down below is an x squared, but the x squared is trapped inside of a radical. So let's think this through. We have our x squared inside the radical here. So if we divide everything by x squared, that's our largest power down below. What we're really doing, if I were to take this, actually, get rid of one of those. There we go. If I divide this by x squared, I'm dividing inside the square root. If I take it on the outside, we got x squared minus 2, and x squared is x times x. And with square roots, we're looking for a pair of something, so that comes out in front as a 1 over x. X squared minus 2. So what we're really doing is when we divide by an x squared in the square root, we're actually dividing the bottom part by x. So we'd have to divide the top part by x. So let's go ahead and do that. Okay, so we'll divide top part by x. And we're going to divide the bottom part by x. Now, when I say divide by x, I'll go ahead and put it to the side here, like that. And so then we got limit as x goes to infinity, x over x is 1. If I take that inside the radical, 1 over x becomes 1 over x squared. So we're dividing that by x squared, and we're dividing this by x squared. I know that seems weird, but when you're dividing by x squared in the square root, then you're actually dividing the top part by x. Now this gives me 1. So I got limit as x goes to infinity of 1 over square root of 1 minus 2 over x squared. And now we're ready to plug in our infinity. So I'm going to have 1 over square root of 1 minus 2 over infinity squared. And again, 2 over infinity squared, that goes to 0. So this is 1 over square root of 1 minus 0. Which 1 over square root of 1 just gives us 1. And that's our answer. Let's take a look at this problem. Limit as x goes to infinity of sine 1 over x. Well, let's just go ahead and do a straight substitution on this. Even though technically we're studying it as x approaches infinity, we can still plug it in to think of it through along those lines. So if I put infinity in for the x, I have 1 over infinity, which is 0. So we got sine of 0. Here's our angle 0, and our point is 1, 0, and sine on a unit circle is the y portion. So sine 0 gives us 0. And that's our answer. Let's take a look at this one. So we got limit as x goes to negative infinity of 3 plus 2e to the x. Well, let's just plug it in. So we got 3 plus 2e to the negative infinity. Now, e to the negative infinity. We can get rid of a negative exponent by taking the opposite where it's at in a fraction. So I'm going to take the e to the negative infinity to the bottom, becomes e to the positive infinity. Well, 2 over infinity goes to 0. So e to the infinity is just going to go to 0 faster. So this becomes 3 plus 0, which gives us 3. Let's take a look at this one. Got limit as x approaches infinity of 1/2 plus natural log of x squared minus 3 over x squared. So we got limit as x goes to infinity 1/2 plus, now this isn't a single fraction, but we can look at this piece right here and treat this as a single fraction because it is 1. And we're going to divide by x, the largest power in our denominator downstairs, so which is x squared, so we're going to divide everything by x squared. So we've got natural log of x squared over x squared minus 3 over x squared all over x squared over x squared. Okay, so we got limit as x goes to infinity of 1/2 plus natural log x squared over x squared is 1 minus 3 over x squared all over x squared over x squared is 1. Limit as x goes to infinity of 1/2 plus natural log of 1 minus 3 over x squared. Well, let's go ahead and plug in the infinity for the x. So we're going to have 1/2 plus natural log of 1 minus 3 over infinity squared. That. Now, again, 3 over infinity would go to 0. So 3 over infinity squared just goes to 0 faster. So this becomes 1/2 plus natural log of 1 minus 0, which gives us 1/2 plus natural log of 1. And natural log of 1 is 0. So this is going to end up giving us 1/2 as our answer. So let me save that. And this is limits at infinity. So I'm going to go ahead and upload it to YouTube.